which this is a fraction, this is a fraction. If you have fractions, if you can cancel, okay, you can factor and cancel, then you have a whole. If you can't cancel, you have a gap, okay? Whole and gap. So let's say I had this, f of x equals x squared plus x minus 6 divided by x minus 2, and they want to know what type of discontinuity do we have. Well, I see if I can factor this. This factors to x plus 3 and x minus 2. On the bottom I have x minus 2. So I can cancel here. So because I can cancel, then what type of discontinuity do I have? Then that means that I have a whole. Okay, it means I have a whole. Fantastic. Fantastic. So, other things that they can ask. List the places where tangent of x is discontinuous. Okay? Well, I'm going to tell you to take out your sheet. Look at your sheet. A23, I believe that's what it's called. That's a reference to the back of the book, a reference to the back of your Calc book. Okay? In the appendix, A stands for appendix. So if you go in the back and you look for A23, we are going to come up with this little page, and I made copies of this for you. It's in your binder. You should be in your binder. Okay, it should be in your binder. So here are the different things that we have. Okay, so we want to list where tangent is discontinuous. Let's go over to tangent. Okay, let's see, where is tangent? Tangent's right here. Okay, so we know that tangent's going to have some discontinuities because tangent is written this way. The tangent of x is equal to the sine of x over the cosine of x. So if we're thinking about our trig stuff, we know this is going to be discontinuous everywhere cosine of x is equal to 0. So wherever the cosine of x is equal to 0, tangent is going to be discontinuous. This form in your appendix will tell you that. Okay, so I go over here and I look, and this is how you read these things, okay? It says the domain x can't be pi over 2 plus n times pi. So what does that mean? We have discontinuities at pi over 2. Now, the period, which means how much it repeats, is pi. So here's pi over 2. This would be 3 pi over 2. And if I were to add pi to that, and since my denominator is 2, okay, if I took 3 pi over 2 and I add pi, whoops, I would add 2 over 2 pi, because that's equal to 1, but my denominator is the same. So that's going to be 5 pi over 2, and then if I add 2 over 2 pi again, it's going to be 7 pi over 2, and I'm going to put some dots telling me that it's going to continue in that direction. And then over here, I'm going to have negative pi over 2, and then I'm going to have negative 3 pi over 2, dot, 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 in that direction. Okay, so I did what they asked me to do. I listed where it is discontinuous. Now, they could ask for the same information in a different way. Okay, they could ask for the same information in a different way. They could say this. List the intervals of continuity. For tangent of x. So now we want to list where it's continuous. Well, let's look. This is continuous from negative pi over 2 to pi over 2, but it can't include those. So that's why I have a parenthesis written here. Negative pi over 2 to pi over 2. And then I'm going to go pi over 2 to 3 pi over 2. And then I'm going to go from 3 pi over 2 to 5 pi over 2. And then I'm going to put some dots on that side. I'm going to put some dots on that side. Okay, that's listing where it's continuous. Okay, so I want you to do the same thing for cotangent. List where cotangent of x is discontinuous. And then list the intervals where cotangent of x is continuous. I want to make sure that you can do both of those. Okay, so please do that now. Okay. So if you haven't had time to do that, please pause that video. Pause it. Pause it. See what you have here. All right. So where is we're doing cotangent, right? So cotangent is here. So if we want to list where it is discontinuous, everywhere there's an asymptote. So at 0, at pi, at 2 pi. So at 0, at pi, at 2 pi, at 3 pi. And then here at negative pi, at negative 2 pi, and so on. Now if I want to list where it is continuous, I could say from negative pi to 0 with parentheses, and then from 0 to pi with parentheses, and then from pi to 2 pi with parentheses, and then throw some dots in there. Okay? So, that's all about being discontinuous. Okay? All about being discontinuous. Just checking the time here. What do we got? 9 minutes into the second video. All right. All right, so we can do this. We can do this. So, don't forget, I could ask, is this function continuous? What type of discontinuity do we have? Or say, list where continuous. Those are all the different things that we could say. So let's go back to that removable discontinuities. Poles are removable discontinuities. Okay? Because we can, create a piecewise function to plug the hole. So let's say we had this. F of x equals x squared plus 2x plus 1 divided by x plus 1 if x equals a negative 1. Well, I should say x doesn't equal negative 1. Because when x equals a negative 1, we have a problem. Okay? So what I want to do here is I want to make this a piecewise function. So let's think about what we have. Okay, let's think about what we have. We have this function, and I have no idea what it's going to look like. Other than, if I'm taking something that's an x squared and dividing by an x, I'm going to get an x to the first power. So I'm going to get something that looks like a line. And then at negative 1, I'm going to have a hole. So what I need to do is, I need to come up with a piecewise function that's going to fill this hole, okay? Now, we talked about earlier that if you have a hole, that means that you can cancel. So let's take this over here off to the side, x squared plus 2x plus 1 over x plus 1. And let's see if we can cancel. Now, don't do this. You do this, probably puke. Cancel these ones, cancel, no, you can't do that. You get a factor. So this is going to be x plus 1 times x plus 1. Now let's look at what happens when I cancel. I can cancel this, I can cancel this. I'm left with this function, x plus 1. So if I plug a negative 1 in here, plug in a negative 1, I get negative 1 plus 1 is 0. So my piecewise function, if x doesn't equal negative 1, this is my function. When if x equals negative 1, I need that to be a 0. Because the 0 is what's going to plug that hole. Okay? The 0 is going to plug that hole. So let's look at another, copy that down. Copy that down. Let me give you another example. Pause it if you have to. So let's say I had this, f of x equals x squared plus 5x plus 6 all over x plus 2. And I'm going to say something like create a piecewise function to fill the hole. Create a piecewise function to fill the hole. Okay? Work your magic. Work your magic. Use mine as a guide. I'll start in a minute for those of you guys that aren't brave enough to do it on your own. right, so hopefully you guys got a beat on this one. So let's f of x equals, we know it's going to be x squared plus 5x plus 6 divided by x plus 2. Well, what's going to make my denominator 0? So as long as x is not a -2, and then we got to do down here, we got to figure out what to do when x is -2. We got to figure out how we're going to plug that hole. So I take this and I factor it. X plus 2, x plus 3, that's over x plus 2. These things cancel. Let's plug that -2 in now. -2 plus 3 is 1, so we would make this a 1, and that would plug the hole. Okay? So, one last problem with these. Find the value of c that would make the function continuous. On negative infinity to infinity. All right? And they give us this. F of x equals x squared plus 3x plus c if x is less than 2, and 2x minus 1 if x is greater than or equal to 2. So, let's see. So what I'm going to do here is I'm going to plug in a 2 here. Plug in a 2. Okay, this is what it tells me, x is greater than or equal to 2. So I'm going to plug a 2 in here. So I get 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. So now I'm going to set this equal to 3. X squared plus 3x plus c equals 3. Okay, and then I have to take that 2 and plug that 2 in for x. 2 squared plus 3 times 2 plus c equals 3. What's that going to be? 4 plus 6 plus c equals 3. 10 plus c equals 3. C equals a negative 7. All right? Let's wrap this up. Let's wrap this up. I'm getting there. Okay, I'm getting there. Again, you can always go back and pause it and do whatever you got to do. So let's discuss the continuity. Okay? 1 is going to be f of x equals 1 over x. 2, g of x equals x squared minus 1 over x minus 1. C is going to be h of x equals x plus 1 when x is less than or equal to 0. X squared plus 1 when x is greater than 0. And d, y equals sine x. So I want you to take a look at those and discuss the continuity. Talk about if it's continuous everywhere, are there discontinuities, that type of thing. So if you haven't, pause your video, okay? Pause your video. So let's look at this one. Discuss the continuity. We know it's not continuous everywhere. We got a letter in my denominator. Okay? The letter in my denominator is going to create a problem. So x can't be 0. So we would say continuous